The Internet of Things is a term that has rapidly become a part of our everyday vocabulary, but oftentimes people don't fully understand its meaning or just how far it spans. In 2013, the Global Standards Initiative on the Internet of Things defined it as the infrastructure of the information society. The IoT allows objects to be sensed and or controlled remotely across existing network infrastructure. This then creates opportunities for more direct integration of the physical world into computer-based systems and results in improved efficiency, accuracy, and economic benefit, as well as a reduction in human intervention. But how does this impact you? Well, that is simple. With today's consumers' demand for cyber-physical systems that encompasses technologies such as smart homes and intelligent transportation, the future looks like anything that can be connected will be connected. Think of where we are today. The everyday person using Nest to control the temperature in their homes and turn on lights from their smartphone, or, with a push of the dash button, order paper towels. Now imagine the future where your car may be able to text someone to let them know you are running late, or where your alarm clock alerts your coffee maker that you are awake and will be expecting coffee. The IoT world is evolving. Every day, new ideas are on the horizon, driving developers to make them a reality. Doesn't it make you wonder what tomorrow will bring? The ESP8266 processor is an 80 MHz microcontroller with a full Wi-Fi front end. Because some users found it difficult to work with, mainly because it was not breadboard friendly, Adafruit designed the huzzah breakout board. There are several other boards such as the Feather, but today we are going to focus on the huzzah. Before working with this device, it is important to understand how the input-output pins work and their purposes. There are 4 types of pins, those being power pins, serial pins, general purpose input-output pins, and analog pins. First, we are going to focus on power pins. The ESP8266 requires 3.3 voltage power. So, a high current capable 3.3 voltage regulator was put on the board. There are 2 inputs for the regulator, the V+ and the VBAT as shown in this image. The V+ pin is also on the FTDI serial header at the bottom edge. Secondly, there are serial pins. The RX and TX are the serial control and bootloading pins. This is how you will spend most of your time communicating with the ESP module. The TX pin is the output from the module, and the RX pin is the input into the module. Next are the general purpose input-output pins. This breakout has 9 general purpose input-output pins, those being 0, 2, 4, 5, 12, 13, 14, 15, and 16. All of which are 3.3 voltage logic level in and out. However, they are not 5 voltage compatible. The maximum current drawn per pin is 12 mega ohms. These pins are general purpose pins and can be used for any sort of input or output. Lastly, there is a single analog pin called A. This pin has a 1.0 voltage maximum. So if you have an analog voltage you want to read that is higher, it will have to be divided down to 0 minus 1.0 volt range.
Hi, I'm going to be showing you guys how to use how to install the Arduino IDE, and this is the Adafruit, learnadafruit.com. This page has a lot of good information. You can pretty much get anything. It has a FAQ. If you ever have any questions with, if you have a problem with, if you come across a problem and you don't know how to approach it in any way, you can check this section out. And majority of the times, they will tell you if that problem has been solved before you. After that, what we're gonna do is one thing actually. In order to use the ESP8266 with Arduino IDE. If you have if you have a Mac, it's going to be really difficult for you because there have been times that if you have a Mac and and you use the actual FTDI cable, it doesn't really work because you need an extra drivers that you need to install. For example, the PL2303, that's the driver that you would need to install in order for the FTDI cables to work, or the console cable to work. Even with Windows, um, when you first plug in, it might not work, and you will have to update your drivers, or once you update your drivers, you should be good to go. Um, the next thing we're gonna do is show you how to the installation website. So you need to download or install the latest Arduino IDE, and that's where you can get that from this website, their own website, arduino.ccc. And from there you go down here, you go to the hourly builds, and you click the Windows, whichever environment, whichever operating system you're using, you choose, and then you download. Once you install that, the next thing you would have to do is copy this and paste it exactly where it says, the additional board manager URL. You have to put that in here exactly as it is, or if you don't do that, Arduino is not supported. So if you have this chip and you have the Arduino IDE and you do not have the packet, if you do not have the ESP8266 board package, it's not gonna work. So you have to have that in your IDE. Once you do that, the next thing is you go to the board manager and install the ESP8266 package. I'll be showing you guys that in a few minutes. And then after that, the next thing you do is set up support. You go to the Adafruit. You go to the IDE and then board, and then you choose your desired board, which is in our case is the huzzah ESP8266. And after that, you can just follow along this super easy, and your pod rate should always be 5200 pod upload. And then and make sure that the COM or serial port for your FTDI or serial port cable is matching your port. Now I'm gonna show you guys the actual IDE. So for this one, so this is the Arduino IDE in Mac. So this is about Arduino preferences, services. A lot of times you're not gonna use this. So most of the things that you're gonna use is the examples. These are pre-uploaded or preloaded sketches or code that is ready to go. So for example, you could choose the blink. Once you choose that, all you have to do is wire up your stuff, your ESP8266, and test it out. Once you're able to send signals to ESP8266, you're good to go. The next thing is you're gonna have to know is your serial monitor. This is your serial monitor. This is where you get all of this, where you can track of exactly what's on here, your code. It will tell you, like for example, if you're trying to connect to our internet, to the Wi-Fi, it would say connecting to, and then to the exact SSID name. So with the serial monitor, you have to exactly, if you don't set the right rate part, you're gonna see some gibberish stuff. You're not gonna be able to read it. So a lot of times the code exactly right here in the void section, in this section it would say serial.begin. So this initiates that when the code starts, it's gonna start at 9600, pod rate. So once the code is uploaded, all you have to do is pull up the serial monitor and then set that to 9600, and you should be you should be good to go. The other thing that I want to show you guys is if you want to add a library, is you can say you can add a zip library, and then in this section you can also add you can add a file. You can add the library as a file, and then so include library. This section is libraries that come with the Arduino IDE, and some of them that I have downloaded. A lot of these things are once you download the package, the ESP8266 package libraries, you're gonna get all this stuff, and you'll be able to play around with it and stuff like that. And then the next biggest thing that I want to show you guys is the board. Yeah, the board manager. So for example, in this section here, you can search anything. For example, let's say sensors. If I want to download a library a sensor library. Yeah, for example, this one. All you have to do is install, and it will show up. It show up right here in your library, in your include library. It will show up here as soon as I download. The other thing is you have to have the right board. If you don't have the right board, you're not going to be able to compile or upload anything. So you have to have the right board checked. If you use let's say if you use the generic module, some codes might work for you, some might not. So you really have to be careful. So yeah, you really have to be really careful, or else it's not gonna work.
So now I have the blink test right over here, and as you can see, you're just gonna have to go ahead and modify the coding. Let's put the pin mode, it's 4. Then, if you remember, I put in I put in 4 as a digital pin, and from there, let's go ahead and see. Let's go ahead and upload it. Take about a few seconds here. Okay, so now it's sending the data to my microchip. All right. Okay guys, so I have the Adafruit Huzzah here. We're gonna go ahead and do a blink test. We're gonna need an LED light, a resistor, zip wires. As you can see, I have like 3 here. Then I'm using a USB cord connected to the microchip so that it could send out data to the USB port, and plug this into the computer, and that should send out the data and the codes back to the microchip, and then from there it would input the codes and make this thing blink. So once it was sent out, as you can see, it's blinking like the way we wanted to. That is the blink test for Adafruit Huzzah. For more information, just check out the Adafruit IO if you want to learn more about it. Read through it and see how everything works. Other than that, thanks for watching.